Distance problems occur frequently in real life. If you're traveling on a highway for 3 hours at a steady speed of 60 miles per hour, you would expect to cover 180 miles. What you would do would be multiply your rate, 60 miles per hour, times the time you were traveling that speed, which is 3 hours, and you would get 180 miles, the distance you've traveled. You're traveling for 3 hours at 60 miles per hour. You cover 180 miles. Notice that the units cancel out, and the final answer is in miles. 60 miles per hour for 3 hours, you cover 180 miles. This is an example of the formula, the basic formula for distance problems, which is that d is equal to r times t. Distance is rate times time. The distance that you travel is equal to the rate that you're going at times the number of hours that you're traveling at that rate, or the time you're traveling at that rate. We assume, of course, that the units are the same. If you had your rate in feet per second, you would want your time in seconds so that the units would cancel out and your distance would be in feet. So the units should match out. Now, let me give you another variation on this idea. The distance between two cities is 220 miles. If you must travel from one city to the other in 4 hours, what steady speed must you maintain? Okay. Once again, we go to our formula. Distance is rate times time. This time, however, I have told you the distance that you have to travel. That's 220 miles. We are looking for the rate. And I tell you the time, you've got to accomplish the trip between the two cities. You have to complete that trip in the 4 hours. Dividing both sides of this equation by 4 hours, we get that r, because the 4's cancel on the right-hand side, 220 over 4, which is 55. And notice that the unit's miles per hour. Four hours, divide both sides by 4 hours. The distance divided by the time gives you the rate. You must travel at an average speed of 55 miles per hour to go between these two cities, to travel between these two cities 220 miles in the 4 hours. Now, the basic formula, as I mentioned before, is that distance is rate times time. Sometimes the problems get a little bit more complicated. Very often, you must read the problem very carefully and look for some common sense idea that's inside the problem. You usually have to provide, okay, a certain amount of common sense in a distance problem. Let's look at this example over here. You don't have to copy it because you have it on your sheets. Okay, if you don't have a copy of the sheet for this particular videotape, turn off your machine, go over to the attendant, and get a copy. Okay, this is the first problem. Now, let's read it now. Jack leaves New York for a business meeting at 7 a.m. and drives south at an average speed of 50 miles per hour. 1 hour later, his wife realizes he has forgotten several important documents and immediately sets out to overtake him. If she drives south on the same highway at an average speed of 60 miles per hour, at what time will she catch him? A very dedicated wife here, and she is going to catch her husband and give him those papers. Okay? Now, she is starting out an hour later than him, but she is going faster, and she hopes to overtake him. Our job is to find out what time will she catch up with him. Okay, now, the common sense idea that you have to provide in this particular problem is that when she overtakes him, they will have each covered the same distance. Jack is traveling. He will cover a certain number of miles when his wife reaches him. When she reaches him, obviously she's covered the same distance. Okay, and that is the key to the problem. Okay, so when she overtakes him, they will have each covered the same distance. Okay. Let's use our basic formula. Distance is rate times time. And I'm going to use subscripts here to indicate that the distance that Jack travels is the rate that Jack is traveling at times the time that Jack travels. And the distance his wife travels is equal to the rate that his wife is traveling at times the time his wife travels. Our basic formula, D equals RT, subscripted for either Jack or his wife. Now, when she overtakes him, they will have each covered the same distance. Okay, so when she overtakes him, dj is equal to dw. The distance traveled by Jack will have to be equal to the distance traveled by his wife. Okay, she overtakes him when they've each covered the same distance, when she catches up to him. Okay, now let's see what information is provided for us in the problem. See, we're trying to set up an equation. dj is equal to dw. Now, dj is rj tj, and dw is rw tw. In the problem, we are told rj and rw, the rate that Jack is traveling at and the rate his wife is traveling at. Okay. Now, our unknown in this case has to do with time. Okay. Let's let x equal the number of hours for Jack's wife to overtake him. That's what we're going to work out. At the end, we'll figure out the number of hours for Jack's wife to overtake him, and then we'll figure out at what time she actually catches him. But right now, we're going to be looking for the number of hours, okay, that she'll have to travel before she overtakes him. Okay, from this variable x, we're going to find tj and tw, okay, the time that Jack is traveling, the time his wife is traveling. Now, clearly, x, the number of hours for Jack's wife to overtake him, that's the number of hours that Jack's wife is going to be traveling. This must be your tw. The time that his wife is traveling, that's the same as the number of hours for her to overtake him. She will travel until she overtakes him. So that's tw, and that is x. Okay. Now what you have to think about for a moment is how to find tj, the time that Jack is traveling. Let's go back to the problem. Jack leaves New York at 7 a.m. 1 hour later, his wife realizes he's forgotten the document and immediately sets out to overtake him. So if she is traveling X hours, since he started an hour before, he started at 7, she's starting at 8. Okay? He started an hour before. He must be traveling X plus 1 hours. Okay, so X plus 1, that's the time that Jack is traveling. His wife travels X hours. That's the number of hours to overtake him. Since he got in the car an hour before, he will be traveling X plus 1 hours. Okay, let's go back over here. We're going to substitute for RJ, TJ, RW, TW, and we'll solve for X. Okay, now RJ, the rate that Jack is traveling at. Jack leaves New York. He drives south at an average speed of 50 miles per hour. Okay, so RJ is 50 miles per hour. TJ, the time that Jack is traveling, is x plus 1 hours. RW, the rate his wife is traveling at. Okay, his wife is driving south at 60 miles per hour. Okay, so RW is 60 miles per hour. And TW, the time his wife is traveling, is x hours. Okay, while in the very simple problems, I put all the units in, explicitly the miles per hour and the hours. Okay, in more complicated problems, we tend to leave the units out. And at the very end, we look at what we're trying to find. For example, x number of hours for Jack's wife to overtake him. And we know that the answer, or if we solve this equation for x, the answer will be in hours. Okay, so you don't have to actually keep your units all the time in the equation. Okay, let's go back over this equation. We have the rate that Jack is traveling at, 50 miles per hour, the rate his wife is traveling at, 60 miles per hour. She travels for x hours. He travels 1 hour longer because he started an hour earlier. He travels for x plus 1 hours. Okay, and we are interested in finding when the two distances covered will be the same. That means she has overtaken him. Okay, let us solve this equation here. We distribute the 50 on the left-hand side. 50 times x plus 50 equals 60x. Now we will subtract 50x from both sides. Okay, we have the 50x is canceled here. Over here we have 50 equals 10x. Dividing both sides by 10, we find out that x is equal to 5 hours. X equals 5. Okay, it's 5 hours. X is the number of hours for Jack's wife to overtake him. It takes 5 hours for her to catch up with him. She will travel for 5 hours. He will travel for 6 hours. Okay? The question, however, always make sure you're answering the question that was stated here, that was asked here. At what time will she catch him? Okay. She starts at 8. She travels for 5 hours, so she will catch him at 1 p.m. Or you could say he starts at 7, and he travels x plus 1, 6 hours. So he, once again, 1 p.m. Okay, if you will go back to our equation here, you will see she will travel 60 miles per hour for 5 hours. She will cover 300 miles. He will travel 50 miles per hour, but for 1 hour longer than her. She's traveling 5 hours. He's traveling 6 hours. So he'll go 50 miles per hour for 6 hours, covering 300 miles. She'll go 60 miles per hour for 5 hours, also covering 300 miles. She will catch him at 1 p.m., give him those papers, and go back home. Okay, and that's the end of that problem. Okay, let's now look at example number 2 on your sheets. Okay. Here we have a round trip problem. Mike is going to go from city A to city B, and then come back again from city B to city A. He goes traveling at 50 miles per hour, but on the trip back, traffic is heavy, only averages 40 miles per hour. We are told that the whole trip from A to B and back to A, okay, takes him 9 hours. We are interested in the distance between city A and city B. Okay. And there is a common sense piece of information here, something that you have to provide to solve the problem. Okay, in the last problem with the overtaking, you knew that when she overtook Jack, they had traveled the same distance. Here, the common sense piece of information that you have to provide is that the distance from city A to city B is the same as the distance from city B to city A. In other words, the distance going is equal to the distance returning. Okay. The distance going must be equal to the distance returning. The cities are not moving, okay? Mike is doing all the traveling. He goes from A to B, and then from B to A. The distance going is equal to the distance returning. Okay, the distance going equals the distance returning. Now, distance is rate times time. So, the rate going times the time going must be equal to the rate returning times the time returning. We are told his rate going, which is 50 miles per hour, and his rate returning, which is 40 miles per hour. Okay, we're interested in the time going, the time returning. We are told the total driving time is 9 hours. Okay, that is that the time going plus the time returning together equals 9 hours. So we can start by saying let x equal the time going, okay, the number of hours, okay, it takes to travel from A to B. And then 9 minus x would be equal to the time returning. You could have set it up the other way. You could have said let x be the time returning, and then 9 minus x is the time going. The only important thing is that the tg plus tr be equal to 9. The time going and the time returning. Okay, the round trip comes to 9 hours. And this can be broken up either way. X is the time going, then 9 minus x is the time returning, or the reverse way. It doesn't matter as long as you're consistent. Okay. Here we have x is the time going, 9 minus x is the time returning, and the rate going is 50 miles per hour. The rate returning is 40 miles per hour. We plug into this formula. Okay, now we're going to substitute into this formula. Okay, we know the rate going, we know the rate returning, 50 miles per hour and 40 miles per hour. If the time going is x, the time returning is 9 minus x. For example, let's say it takes him 2 hours to go. Since the round trip is 9 hours, okay, the return trip must be 9 minus 2, or 7 hours. Okay, 2 plus 7 would be equal to 9. So in other words, if you know the time going is 2 hours and the return trip is 9 hours, you subtract the 2 from the 9 to get the 7. And the same thing we're doing here, but we're doing it with an unknown time going. The time going is x. The time returning is 9 minus x. OK, substituting into this formula here, I'll just rewrite it here. RGTG is RRTR. The rate going, that's 50 miles per hour. The time going is x. The rate returning is 40 miles per hour. The time returning is 9 minus x. Just make this a little r so the notation looks the same. Okay, just substituting here the values that we found. Now we're going to solve this equation for x. This is our key equation here, and we're going to solve this for x. 50x is equal to, now distribute the 40 through the parentheses, 40 times 9, 360 minus 40x. Add 40x to both sides, and we'll get 90x is 360. Divide both sides by 90. X is 4. X, of course, is the time going. It's in hours. X is 4 hours. OK, let's see what we have. X is 4 hours. The time going is 4 hours. Therefore, the time returning must be 5 hours. Okay, 9 minus 4. Okay, if x is the time going, which we found to be 4, then 9 minus 4 is the time returning. The total trip taking 9 hours going and coming. Okay, now, is that the answer to the problem? What was the question? What is the distance between city A and city B? Okay, we have found the time takes him to go from A to B, the time to return from B to A. But that's not the answer to the question. The question is, what is the distance between city A and city B? Okay, in this case, we want either DG or DR. They will come out to be the same. Let's look at that. dg and dr. dg is rg/tg, dr is rr/tr. Okay. He's going at 50 miles per hour, rg. He goes at 50 miles per hour for 4 hours. He covers 200 miles. Now, obviously, if we've done this problem correctly, the distance returning should be the same. He's going at 40 miles per hour. The return trip takes 5 hours, also 200 miles. So the answer is 200 miles. That's the distance between the two cities. And we've also checked our work here. We see that if he goes at 50 miles per hour for 4 hours, he covers the 200 miles, and returning 40 miles per hour for 5 hours, also covering the same 200 miles. Now, in the first two examples that we worked out in this tape, okay, it involved having two distances which we set equal to each other. Okay, and that's how we solved examples 1 and 2. That was for the overtake problem and also for the round trip problem. Now we have a slightly different problem here. We have two cars that pass each other going in opposite directions on a highway. Okay, well, common sense tells us that we're not really interested in what happens to these cars before they pass each other. Okay, as far as we're concerned, the problem starts at the moment that these two cars pass each other. Okay, let's say they pass each other here. Now, one car is going east. At 55 miles per hour, and the other car is going west at 45 miles per hour. Okay, this is the point where they pass each other. This car was coming from here, and he's going here. This one was coming from here. They passed each other here. This is the starting point. And he continues going east, he continues going west. We are interested in how long, okay, will be before they are 300 miles apart. So what we're going to have to do here is add two distances. We want to know when the distance between them is 300 miles. This is the distance that this car travels plus the distance that this car travels. In other words, after they've passed, okay, we want this total distance to be 300 miles. We want to know when the distance is 300 miles. Okay, here you have this one car here, right? Well, it looks like a house on wheels, but you get the idea. And the other car here. And we want to know when the distance between them is 300 miles. Okay, let's say d sub, we want to know when is the distance that the car going west. Okay, when is dw, distance that the car travels going west, plus de, the distance, okay, covered by the car going east. When is the sum of these two distances equal to 300? The distance traveled by the car going west plus the distance traveled by the car going east are going in opposite directions. When is the sum of their distances 300 miles? Okay. Now, dw plus de is to be 300. Now, distance is rate times time. So dw is rate wtw. Distance e is rate going east, time going east, 300. Now, we are told that the car going west is going west at 45 miles per hour. And we are told that the car going east is going east at 55 miles per hour. Okay, now the question is, the time here. Okay, now the common sense piece of information is that they are traveling for the same time. In other words, time 0 is when they pass each other over here. Okay, now they'll be each traveling for the same time, and at a certain point they will be 300 miles apart. So let t equal the time that they'll travel until they become 300 miles apart. So let t equal the time traveled. Okay, it's really in the number of hours. The time traveled until they are 300 miles apart. Okay, the time is the same for both of them. Okay, time 0, they pass. One goes east, one goes west. After a certain number of hours, okay, they will be 300 miles apart. But it's the same number of hours for both of the cars. So let TW and TE both be replaced by T. That's the number of hours traveled until they are 300 miles apart. Okay, let's solve this equation. We have 45T plus 55T is 300. 45T and 55T, that's 100T equals 300. Dividing both sides by 100, T is equal to 3 hours. Okay, how long will it be before they are 300 miles apart? 3 hours. Let's check this. Okay, in 3 hours, the car going west, okay, the distance covered by the car going west is RW, TW. He is going 45 miles per hour. Okay, for 3 hours, he covers 135 miles. The car going east is traveling at 55 miles per hour, also for the same 3 hours. Okay, he covers 165 miles. So that this distance from here to here is 165. This distance from here to here is 135. And together, they will be 300, the distance between them, 300 miles. They will be 300 miles apart at the end of 3 hours. And this brings us to the end of this tape.